Hello guys, we'll do the stimulation of cavity problem in OpenFOAM. So as you can see that uh, the directory of cavity, the path is open, that is the path is visible from home to XYZ foam, then OpenFOAM, then tutorials in compressible, icofoam, cavity and then cavity. So now we'll open this in the terminal. So we'll right click and we'll do open in terminal, and now we have to ensure that the computer knows where OpenFOAM is installed, so we will bash it. Then what we have to do is we'll use the command block mesh to generate a mesh. So I've used the command block mesh, and so here the process is completed. Now we just have to use the command icofoam because we are in the icofoam folder. So as you can see that this has stimulated the flow inside the cavity, these 0 0.1, 0 0.2, 0.3, 0.4 and 4.5 seconds. So yeah, so now let's open the para view. Okay, we'll go on the terminal and now we'll open the para view. Okay. Okay, so till para view opens, what we have to do? Okay, so sorry, para view is open. Now we will okay, wait. So as you when we open the zero folder, we can see that there are two folders over here, P and U. P stands for pressure and U stands for velocity. So we'll open any one of the folders, so you can see that the internal field is uniform, and that in the boundary field we have moving wall, fixed wall and front and back, and we have to know that the lid is there is an open lid. Similarly, when we open the U folder, that is the velocity, we see that the internal field is uniform, and as usual the boundary field has moving field, moving wall, fixed wall, front and back, and the lid is open similarly. So now what we'll do is our para view was open, so we have to, okay, we'll first of all open the folder. Properties, and we'll apply it. So now you can see that okay, oh, okay, one more thing that I forgot is this. As you can see over here that when we saw in U in internal field it was uniform flow, but now when we'll see it in point 1, we can see that the internal field shows it's non-uniform, and there are like 400 or something factors, which 400 or something non-uniform factors. Okay, so now similarly the pressure will also act uniformly. Okay, we saw the pressure, now we'll see that similarly the velocity also acts non-uniformly. Okay, sure. So again, going in the para view. Okay, now we can see that we got a box. So what we'll do is we'll make it U, and this drop box, and make it U. Okay, so now this is our box. As you can see that the lid is open and rest the box is closed. Okay, so the dimension is XYZ. Okay, and so the velocity is so the velocity is flowing in the direction X. So now we'll see the airflow inside the box, and this will see by this. Okay, so these arrows represent the airflow inside the box, and the size of the arrow is really large. So for clarity, we'll just scale it less. apply it. Okay. Oh, really less. Apply it. Yeah. So now this bar shows the intensity, uh, and show the red part shows that the velocity of airflow inside the box is really high at this portion. So we are done here. Now we'll just go on the information tab, and we'll see that um, here these are the bounds of the airflow, and within these bounds our velocity is represented. So thanks a lot. It's done.